So today in the TFA Tech Forum, the TrustedFirmware OpenCI and MISRA testing using ECLAIR, presented by Roberto, Bagnara from Buxton and Paul Sokolovsky from Linaro. It's up to you, folks, to start. Thank you.
Okay, so welcome. My name is Roberto Bagnara, and I am one of the co-founder of Buxton and also one of the main architects of the ECLAIR software verification platform. I'm also a member of the MISRA C working group and of WG14, the C standardization working group, but of course today I am talking in a personal capacity, and what I say doesn't represent necessarily what the MISRA opinion is or WG14 opinion is. Okay, so Buxton is a company that provides tools for software verification. The ECLAIR software verification platform is the main one, and also we provide consulting services and advanced professional training. The team is composed of highly skilled researchers and software engineers that have a lot of experience in software verification. So let me start to recall some of the compelling economic advantages of the C programming language, which is around since 50 years, and there are several reasons why things are as they are. First, C compilers exist for almost any processor, and compiled code is very efficient without hidden costs, meaning that if we set aside the problem of multi-core architectures, an experienced programmer can more or less guess what the execution time of a piece of code will be. C allows writing compact code. There are a lot of built-in operators, and you can code quite complex things by writing a limited amount of lines. It's defined by an ISO standard, and it allows easy access to the hardware, which is essential, for example, to write operating systems or embedded systems. And it has a long history of usage, including in critical systems. And also, C is widely supported by all sorts of tools, not just compilers. There are lots of tools that can operate on C source code or code generated, machine code generated from C. And C also has disadvantages. And well, one of the reasons is that the C standardization working group, WG14, has always been faithful to the original spirit of the language, which we can read from the charter of the working group. This is a literal quotation. So point A, trust the programmer. B, don't prevent the programmer from doing what needs to be done. C, keeps the language small and simple, and D, provide only one way to do an operation. And point E is important, make it fast, even if it is not guaranteed to be portable. Point F was added much later. It was added for C11, make support for safety and security demonstrable. All the other points are well known to be bad for safety and security. So let me summarize where the main problems come from. The main problems come from the notion of behavior, which in the C standard, the old version of it, now I am on the slide, we have a quote from C99, but it's the same thing in all versions of the standard. Behavior is something that you can observe from the external of the program, outside. And so, for example, if I say X++, well, unless X is say a volatile variable, it's not guaranteed that X is incremented by 1. So the compiler does adopt systematically the so-called as-if rule, meaning that the compiler can do any transformation that preserves the observable behavior. The behavior which is observable from outside. So whether if I write X++, and this is not observable from outside, there is no guarantee that the compiler generates code to actually increment X at this point in the program where I'm writing it. Okay, this is true in C, but it's true in many other languages. Basically, it's true in all the languages that admit an optimized compilation implementation. And the reason is that many of the optimization opportunities are in here. Okay. So, well, there are several classes of behavior in C that are not completely defined. We will see three of them. The first class is the class of undefined behavior, which is totally undefined. Okay, behavior upon use of non-portable or erroneous program construct or of erroneous data for which this standard imposes no requirement. And this means no requirement at all. So the program may crash, the program may exhibit all sorts of behavior. For people that doesn't get it, it is said it may format your hard disk, which is actually true, maybe unlikely, but the code to format my hard disk may sit in memory in this very moment when I am talking. And if there is undefined behavior, the program counter may be set to this place in memory where the code to format the hard disk resides, and this might happen. So what it normally means is that the compiler can assume that undefined behavior does not happen. This means that the C language places the burden of ensuring there is no undefined behavior on the programmer. And if there is undefined behavior, it's a fault of the programmer, and there are no warranties whatsoever. So let's see one of the many instances of undefined behavior. It's undefined behavior when the program attempts to modify a string literal. Here we have an example where a programmer is trying to get rid of two of the three exclamation marks by placing a null terminator at position 6 in str. Well, this doesn't work because it's undefined behavior. And one of the reasons why it's undefined behavior is that string literals might reside in read-only memory, and trying to write a piece of read-only memory might result into an hardware exception that at the program level is undefined behavior. Another example of undefined behavior is when you have a stack variable and you read it before it has received the variable. So there are several reasons why it is that way. One of the reasons is that the C language admits trap representations. Trap representation is a pattern of bit that doesn't correspond to any value, and in fact, that might trigger an hardware exception. Think about a memory with parity bits, and think about the possibility that the parity bit is set to the correct value only when the memory cell is written the first time. So here we have a piece of program that, well, it has a stack variable called A, and it reads this variable before A has received a value. So it's undefined behavior. Another class of behavior, which is not as bad as undefined behavior, it's slightly better. It's called unspecified behavior. It is when there are two or more ways to do one thing, and the standard doesn't say which one has to be chosen in any given instance, meaning that the compiler doesn't even need to document what the choice is, and it may make a different choice every time it encounters a certain situation. So, for example, it's unspecified the order of evaluation of expressions. Here we see a main program where there is a plus operator, so it's an expression here, hello plus word. And while it's unspecified whether hello will code first, in which case the output will be hello word, or hello is called second. So word is called first and then hello is called, in which case the output might be word hello, which is probably not what was wanted. And the important thing to be understood is that the compiler doesn't have to document this, and typically doesn't document this. And it can make a different choice depending on the fact that debugging is switched on or off on the optimization level. And also, if I change the program here, not to return immediately, but to compute hello plus word 5 times, each time the compiler might make a different choice. So this is the meaning of in any given instance. Another class of non-completely defined behavior is called implementation defined behavior. It's like unspecified behavior, but this time the implementation has to document how the choice is made, and so the implementation has to be consistent with the choice being made. There are many implementation-defined behaviors. In C11 and C18, there are 119 of those, and some of them are known to everybody. Everybody knows that there are C implementations where int is 16 bits, and there are other implementations where int is 32 bits. So this is one of the implementation-defined behaviors. Here in this example, we see another one. It's implementation defined when you use a char type, the plain char, meaning that you are not specifying signed or unsigned. It is implementation defined whether the representation has sign or not. In the slide, we see a perfectly valid C program that inspects what is the choice being made by the implementation with these options given. And if the standard macro char mean, which is provided in the standard header file limits.h, evaluates to 0, then we know that the plain char type is unsigned. Otherwise, it is signed. So why do we have this situation? We have described undefined behavior, unspecified behavior, implementation defined behavior, and we skipped another variety of non-completely defined behavior, which is called locale specific behavior, which is there for a different reason. So it's for the reason of avoiding barriers to adoption of the C language due to culture and nationality. But for the other classes of non-completely defined behaviors, the one we have seen, the reason is that implementing compilers is easier this way, and also, especially, it's easier to write compilers that can generate fast code, and this is the main driver. So let me show you some examples on how undefined behavior is exploited by the compiler. And in this example, we see another kind of undefined behavior, which is when an exceptional condition occurs during the evaluation of an expression. There are several exceptional conditions. One of those is when there is an overflow in integer arithmetic. Here, the programmer who probably is reasoning like you would reason in assembly code, is coding a function to decide whether a value of type int is the maximum value that's represented in the type or not. And the reasoning is this: if I try to increment v by 1 and I succeed, so I obtain something that is actually greater than v, well, then this was not the maximum value. Otherwise, wrapping takes place. At least this is what happens on a typical machine level, that wrapping takes place. And so in this case, it was the maximum. And the point is that given that signed integer overflow is undefined behavior, the compiler can assume it doesn't happen. And so the compiler can compile, and many compilers will compile this code as an unconditional return 0. Another example concerns the undefined behavior we have already seen, which is a program attempts to modify a string literal. We have seen that one of the reasons is because the string literals might be stored in read-only memory. There is another reason. So suppose that in a program we have two literals, one is tail and the other is head tail. So the first is clearly a suffix of the second, while the compiled program can store in memory only head tail and use a pointer to the fifth character when a representation of tail is needed. So if modifying string literals was allowed, you could change one string and also change the other, but the compiler can assume this will never happen. And so this optimization, the fact of sharing representations of string literal, is perfectly fine. Another example, which is very instructive, has to do with shift expressions. It's undefined behavior when an expression is shifted by a negative number or by an amount greater than or equal to the weights of the promoted expression. So the negative number, let's say, okay, it's reasonable. Okay, why would you want to shift a quantity by a negative shift count? But it's less easy to understand why on earth it is undefined behavior shifting an unsigned 32-bit quantity 32 positions to the left. So if we interpret left shift as pushing zeros from the right-hand side, then if we push 32 or even more zeros, then we would zero the variable. So I should be 0 in the end, right? Well, no, because on very popular architectures like the Intel architecture, the first thing that happens to the shift count is that it is masked. Only the 5 low-order bits are retained. And so on these machines, shifting 32 positions to the left is the same as shifting by 32 position masked this way, which is the same as shifting by 0 position, which is the same as doing nothing. So the value of I would remain unchanged on this machine. So on the first, before we said, well, it should become 0, and now we say it should remain, it should keep its value. So in this and many other cases, the C standard is ensuring that whenever it is conceivable that a high-level operation can be translated into 1 or possibly 2 machine instructions, this can be done. And given that there is a variability between the shift instructions available in different architecture at the machine level, this is why C leaves the behavior undefined in these cases. So one of the things that is very important to understand is that the strength and the weaknesses of C, they come from the same sources. So they are basically not separable from one another because one of the, for example, the fact that it is easy, relatively easy, let's say, writing efficient compilers for almost any architecture, we have seen it's one of the reasons why we have non-completely defined behavior. The fact that we can write efficient code with no hidden costs, it's one of the reasons is that there is no runtime error checking. And the fact that there are many compilers and still the language is defined by an ISO standard is also one of the sources of non-completely defined behavior. So the ISO standardization committees, they standardize existing practice. So let's say if a compiler by IBM and GCC implement a feature in a different way, well, the only possibility to keep the language standard is to have some non-completely defined behavior. The fact that it is easy to access the hardware is also causing the fact that it's so easy to corrupt the program state, for example, by overwriting the stack. And the fact that you can write compact code, well, using the same predefined built-in operators, you can very easily abuse the language and write programs that are very difficult to be understood. So this is the state of things. There are several features of C that are in conflict with safety and security requirements. So the solution that industry figured out is very pragmatic. It's called language subsetting. Basically, you don't program critical code in C, but you code it. You code these applications in a subset of C, which where the possibility of committing mistakes is largely reduced, and in some cases it's eliminated for some kinds of mistakes. And today, the most authoritative language subset for the C programming language is called MISRA C, and that's why we talk about MISRA C. So what is MISRA C? It's a collection of guidelines. So there are now more than 200 guidelines, and they are presented in a book. I just very quickly give you a flavor of how a rule presentation is done. So a guideline as a unique identifier, like rule 5.6, some are called rules, some other are called directives. There is a difference, but I will not go into it today. And there is a so-called headline. So it's a short summary of the guideline. The biggest mistake you can make is that if you read the headline, you will have understood the rule. This is not true. Okay, it's just a reminder of what the rule is about. So rule 5.6 will mean very little to many, but if you have been trained in MISRA, then if you are reminded about the headline, then you will figure out, you will remember what it is about. Then there are several attributes. So let me only go through the first and the third one. So the category, the guideline may be mandatory. So you have to comply. The code has to comply. There is no way. If you want to be MISRA compliant, you have to comply. Or it may be required, meaning that you may comply, or you may have an argument why in a certain set of situations you can't comply, but still safety is not endangered. And you can do this with the required rules. And advisory rules are simple recommendation. You are free to follow them or not, okay? And the guidelines may apply to different versions of the language, C90, C99, or even C11 or C18. And because there are guidelines that don't apply, for example, to C90, because they concern constructs that were added in C only later. And one of the most important sections in the book for each guideline is the amplification. This is normative. So whenever you think, oh, the amplification says something different from the headline, well, it's amplification that wins. The headline is just a reminder. The amplification is the normative part. There is a section about the rationale, explaining to programmers why the rule is there. And this is essential in order to encourage adoption. So programmers have to be reminded of why there is a certain guideline and why it is important to comply. And in some cases, rules do not apply to certain situations. And when for such rules, there is a section called exception that details the circumstances in which the rule doesn't apply. And there always is a section called example showing compliant and non-compliant code. Sometimes rules are connected to one another. In this case, there is a section named C also, with reference to related guidelines. And also there are just below the pink strip, in some cases, there are references to other published sources, for example, the C standard. Here we have a directive 1.1 saying that you have to be aware of the implementation defined behaviors upon which the program is depending, and consequently, the references here are reference to the annexes of C90 and C99, where the implementation defined behaviors are listed. So I will show a very small selection of rules. First, rule 1.1, it basically says that the program has to be written in C. So C syntax, and it has to comply with the constraints given in the C standard, and shall not exceed the implementation translation limits. Every implementation has translation limits. So you cannot. So if we define it a compliant C compiler as a compiler able to compile any program, then there wouldn't be any C compiler, because of course, I don't know, that the machine I'm using here has a certain amount of memory, and if a translation unit is larger than the available memory, the compiler will not be able to compile it. So there are translation limits. And one might think, well, if the compiler accepted that it has to be C, right? It says to comply to rule 1.1. Well, no, compilers cannot be trusted. They typically accept constructs not defined by the language. And also, a conforming compiler does not need to generate diagnostic whenever a translation limit is exceeded. So the compiler says that the standard says that the compiler needs not generate diagnostic, and many compilers do not generate diagnostic, and still they may generate an executable that doesn't work as expected. And also, there are some compilers, several compilers, that technically speaking are not conforming, that fail to diagnose constant violation. The final reason why the rule 1.1 is there is that language features that are outside the supported version of the C standard, they have not been considered when developing the MISRA guidelines. So the guarantees given by MISRA do not apply if you go outside C. Here's an example. So GCC accepts two things, which is returning void expressions. You see here, G returns a void, f of A is an expression of type void. And also it accepts empty initializers. You see, open brace, closed brace. This is a constant violation. This is not C. So some of you might think, hey, well, these certainly are extensions provided by GCC. Well, they probably are, but there is no documentation for them. So in a safety critical development, they basically cannot be used because they are, if they are extensions, they are undocumented. Okay, so this is why you cannot trust the compiler. You need a tool that is being specially engineered in order to flag all the violations of the C standard. A completely different rule. It's about comments. So one might think, hey, what might be the problem with comments? Rule 3.2 says line splicing shall not be used in / comments. And the reason is line splicing is when you have a physical source line of code terminating in a backslash. And so when this happens, the subsequent line is taken as a continuation of the previous line. So here we see a potential problem. So the programmer here the intention was simply to specify a folder in C syntax, but the backslash that is in the comment is such that critical function becomes part of the comment. So critical function was presumably critical and it had to be called, but it will not be called because it's part of a comment. Okay, so that's why we have a rule 3.2. Rule 9.1, it says it's mandatory because it's directly connected to undefined behavior. It says the value of an object with automatic storage duration shall not be read before it has been set because it's undefined behavior. Here we have an example of violation. So if A is greater than 0, then X is initialized before the return statement, but otherwise it's left uninitialized and still the return statement reads it. So possible solution is to add an else branch where another initialization for X takes place. The last rule I will present is connected to unspecified behavior and also to some form of undefined behavior. It says the value of an expression and its persistent side effect shall be the same under all permitted evaluation orders. So we have seen that evaluation orders are typically unspecified in many cases. So it's unspecified behavior, but there are situations in which you have undefined behavior that is connected to violation of this rule. For example, when you modify an object more than once. For example, if you write ++i plus ++i, this is undefined behavior. So you are trying to modify an object more than once between two sequence points. And also the same happens when you are modifying and reading an object at the same time, unless reading is necessary to store in the object. So here we see an example. It's very simple. So we have two volatile variables, and reading from a volatile is a side effect. And given that in function calls, the order of evaluation of actual parameters is unspecified, in this code, we don't know whether the side effect connected to reading TCNT1 will happen before or after the side effect caused by reading TCNT2. So in order to be compliant, we might add temporary variables. And now, given that the execution order of this new code is completely specified, we avoid the violation, and any decent compiler will not let us pay for this extra temporary variables. Let me spend a few words about the ECLAIR software verification platform. The general highlights: it is a very high analysis accuracy. So in the trade-off between speed of execution and accuracy, we have favored accuracy. We have very high coverage. We cover 100% of the MISRA guidelines, MISRA C guidelines up to and including Amendment 3. Amendment 4 has just been published and the implementation of the checkers is underway. And one very important feature is that no configuration is required to adapt to the implementation defined behaviors, because they are collected automatically by ECLAIR. And this is important because, especially in builds where you can use different compilers, different versions of compiler, you can even change the compilation options, and this will typically have an influence on implementation defined behaviors. You will not have to change the configuration of the tool. ECLAIR is also certified by TÜV for using safety-related development according to the major functional safety standards and up to the maximum safety integrity levels. There are other highlights, so it doesn't do MISRA checking alone. It computes metrics, it has a bug finder, it implements stylistic guidelines, it has an integrated requirement management tool. It can verify architectural constraints at the software level. So this is instrumental in providing evidence for independence or isolation or segregation or freedom from interference. These are tightly related concepts that are called in different ways in different functional safety standards. From a continuous integration perspective, the important point is that all the users have access to fully detailed reports. And even though they are accessing the reports that have been generated in a facility like OpenCI, well, they can have private, sophisticated filters locally, independently from one another, okay, on their machine. So they can have their own view of the results that have been computed elsewhere. And with an add-on, which is called the ECLAIR Client Kit, they can also use their favorite IDE, and most of them have plugins in ECLAIR. And that's it. Now, Paul, if you want to share your screen.
Yes. Thank you, Roberto, for this introduction to MISRA standard and certain context for it. Let me try to share my screen now. Okay, can you see it?
Yes.
Okay, great. So my name is Paul Sokolovsky. I work in Linara Developer Services, specifically on Trusted Firmware CI team. And yes, the first slide is short introduction to Trusted Firmware project. I guess no one here on the call requires this introduction. I edited just for wider audience. We plan to share the slides. Yes, the point that Trusted Firmware is essentially an umbrella project which has many projects. We initially interested to apply MISRA testing to namesakes from which the umbrella project started. Is Trusted Firmware A and M, but hopefully later we're interested to extend this testing for more projects. Yeah, and talking for CI, continuous integration for the project, it initially started at ARM and was in-house system for CI at ARM, not publicly available. To make it more accessible to community and to extend, it was migrated. A new project essentially started, OpenCI, based on the original in-house system at ARM, and since then it's been improved and extended, a lot of different functionality added, etc. Yes, OpenCI consists of Jenkins CI server, well known in the community. For building, we use virtual builder machines backed by Docker or AWS. And for test execution, we use Linara Lava product, which allows to control DUT's devices under tests, both physical devices and emulation platforms like FVP, ARM tool for newer platforms and CPUs, and QEMU open source tool. Yeah, one important thing to know is that Trusted Firmware CI, OpenCI, is pretty busy system. Daily we run around 3,000 builds. It's like one build is one configuration, so it's pretty heavy, and a lot of work is still underway to add even more configuration to tests, add more specific tests, so it's only growing. So scalability is one of the important tasks to follow the system. So besides just building, so typical CI system just compiles the codes and maybe tests on devices, but besides that, OpenCI also runs different static and dynamic analysis. Starting from simple things like just checking commit messages, maybe some more advanced analysis, for example, order of includes to confirm code conventions. And example, for example, of dynamic analysis is code coverage. Yeah, and one analysis which we wanted to add for a long time is testing for MISRA compliance, and this presentation is, of course, dedicated to it. Yeah, so so usually people do MISRA testing to achieve MISRA certification. And for this certification, you certify a specific software product. And for that, you have like specific code base targeted for specific hardware platform using specific configuration and built with specific compiler, its options, etc. Yes, but that's not what Trusted Firmware project is. As mentioned before, we have like very many configurations to build, to support, and there are very different options which can vary from build to build. So we cannot just get MISRA certification for Trusted Firmware A project, for example. So given the situation, what are aims for MISRA checking, MISRA testing for Trusted Firmware? So we would like to establish some baseline quality level in regard to MISRA requirements. For example, and well, the current baseline is making sure that there are no mandatory issues, violations of mandatory rules, as in the code base, and the importance of that is previously explained by Roberto. So essentially, mandatory issue themselves, those operator series. Beyond that, for wider Trusted Firmware community, for example, to address required and advisory issues. Yeah, and we also would like to have some guidelines and best practices for Trusted Firmware members and vendors who actually would like to achieve MISRA compliance for their particular product. Like they take upstream code base, fix all those things which I mentioned. For example, they would support specific hardware product built with specific compiler, etc., etc. So we would like to just give them like initial input how they can achieve, for example, this ECLAIR system. Yeah. So and let me check. Okay. So Roberto already presented ECLAIR system and its features. I would like to emphasize why it is good fit for OpenCI system. So it's really highly configurable, and you can tweak, enable, disable particular rules, configure them, etc., etc. Yeah, and one interesting feature also, mentioned by Roberto, so you can disable rules, but that's not how system is intended to work. And it actually took me some time for that to sink in. Like, for example, we see that particular rule does not apply for Trusted Firmware. So first motion is to disable it. But that's not how system recommends. It recommends to capture like all situation regarding all the rules, all the MISRA rules, all the violations, for example. But then when generating particular report, those violations can be filtered. And actually, even for produced report, there are essentially dynamic filtering, so different users can look at the MISRA compliance situation for different subset of MISRA. And of course, it runs in batch mode, like console application, not just like fancy GUI. There is definitely GUI add-on for ECLAIR, but can easily and very nicely run in batch mode. Yeah, and I mentioned already reports. Yeah, so one major challenge supporting ECLAIR was again related to the situations that trusted firmware is a framework with very many options. But ECLAIR works standardly in the way which I mentioned related to MISRA certification. It works with a particular product essentially. So in our case, how we initially started with it is we run ECLAIR on, we could not definitely run on many hundreds configurations as we run complete CI for, but we selected, like, for example, 15 configurations and built them one by one, and of course produced 15 reports. The problem, of course, that 15 reports is not something which one can follow closely, especially that like around maybe 80–90% of content is just repeated. Like there is core code base, like hardware independent code, and then just code for particular hardware system. Yeah, and resolving that was one of the like main important integration challenges with ECLAIR. And it's not actually specific to ECLAIR, because for all other analysis which I mentioned, for example, code coverage, some other static check, and we already faced this situation. And there was like two, based on the previous experience, there were two ways to address that. So one is like produce, still run different configurations independently, producing like some internal representation of information of report, then merge them in some way, and then produce like actual human readable report. That was used, for example, for code coverage. Another example is like set up context for static checking or just analysis and run several configurations in a row and like accumulate data for them. And yeah, so as I mentioned, initial our setup was producing independent reports, but with a second like iteration of work of applying ECLAIR testing for Trusted Firmware M project, we consulted with Bagnara, and it turned out that it's possible to run in that second way, just run a number of configurations in a row, and in such way to produce cumulative report. So instead of independent, like dozens of independent reports with largely repeated content, we get a single report which much more human readable, etc., and actable. Yes, so I don't know. I added a couple of slides regarding specific deployment. So ECLAIR is a proprietary tool, and of course, a lot of effort went into developing, and it's still supported, developed, etc. So it comes with a license server. You cannot use it without it. So there are advanced strategies for using this license server, and one of the challenges was deploying it on our site, on the site of Trusted Firmware OpenCI. We had some iterations with it. We appreciate Bagnara's help with that. So it was deployed and works pretty well after that. And yeah, so we follow the same process with Bagsang as with our other builds and tests. So we have Docker images, which includes in this case ECLAIR, toolchains, etc., and we run our analysis in Docker containers. And here, like overall diagram how it works. So there is Jenkins controller, main server, so GUI. It starts a worker which hosts Docker containers. Docker container on initial startup requests a license key, which automatically expires after some time, even if we don't return it. Yeah, so it's all work pretty robust. Then there is build process, which is going to be like a number of configuration with latest iteration. And after that, we produce fully self-contained HTML plus JavaScript reports, which can be browsed by anyone using browser. And there are still even some GUI for it, which allows filtering. And another very interesting and important features, which was important for us, is testing separate patches. So we do run like baseline testing of the entire code base, but based on the situations that Trusted Firmware has a lot of legacy code, we have like many violations of rules beyond mandatory. So mandatory all addressed, but there are still like a lot of required, etc. And our aim like is again to at least support existing baseline to make sure that new patches coming from the community do not regress the current state of affairs. And that also one important feature which is supported by ECLAIR. So how it works that we build run ECLAIR analysis before the particular patch, without the patch, then with. And ECLAIR has a very nice advanced feature which it allows to differentiate these two reports. And of course, it happens not on a line by line or character by character level, but on the level of deep language constructs. So it's a very nice feature. Yes, so that's for text presentation. In the slides there are like some screenshots, but I would like to now switch and give hands-on presentation for as many minutes we have, like how it looks like on the real server. So here is Jenkins page, and these are all jobs related to Trusted Firmware A. So we have, for example,
see it.
Cannot see?
I can't. Can anybody else?
Yeah, let me try again.
No, it's blank.
What about now?
Still blank. Oh,
There.
Okay, maybe I'm doing.
we had it for a few seconds.
Okay, let me try again. I hope now you can see it.
Yes, thanks.
Okay, great. Yes, so this is daily baseline build which runs across the whole code base. And as you can see, there is what I mentioned, that initial implementation for TFA runs separate configurations, like makes independent reports. And this is going to be like ported, upgraded to produce a sync report very soon. Yes, so we click on the build, and MISRA report is archived as a build artifact. So you should click on build artifacts. And here we produce like some index page, because for initial usage it may be not familiar for people, so there is some index page. So let's look at mandatory rules and specifically violations. That's what I mentioned, that Trusted Firmware A code base does not. So you have here empty space. It means there are no violations of mandatory rules. So it's okay. And violation is ECLAIR specific. So it's not MISRA thing. It's ECLAIR specific situation when it can formally prove that there is some issue, for example. And another like level of issue is caution. Caution is not formally proved issue, it's essentially heuristics, like something which may be wrong. And as you see, there are like some cautions for mandatory rules. So this is a diagram which shows like particular MISRA rule. That's something which was explained by Roberto. So there is rule number 21 section and 18 like specific rule. And this prefix, it means that particular version of MISRA standard, because there are several versions by now and different versions for C, C++, etc. So there is particular rule, and as you see, you have this like title. Sorry, I forgot that specific term, like title of the issue. Then you can see that which source files like have this issue. And you, for example, can click, so this common /UUID, and get like textual explanation what's wrong. And if you hover cursor here, it shows like actual source code. Yeah, so in short, that's all. I see that we are like almost time is running out. I guess it would be nice to leave for 5 minutes for questions.
I see there are 5 minutes left, and Varun raised his hand. Perhaps you can go to questions now. Varun, are you there?
Yeah, thank you. So actually, multiple questions. First one is, I saw that the scans currently are running on only ARM platforms. So if we have to add non-ARM platforms, how would that be? Is there capacity available for that? And yeah, I mean, basically, if we have to add it, how do we add it? And yeah, what will be the process?
Okay, yeah, I'm sorry, I maybe didn't get all the details of the question, but yeah, I guess it's like potentially adding testing for additional branches like LTS. Is that it, Varun?
No, additional platforms. So right now we are running for FVP, Juno. Let's say I want to add another platform.
Yeah, it definitely would be possible. Like when initially working on it, I got the list of configurations we would like to test. It was around 15. It's definitely possible, but as mentioned by Roberto, MISRA analysis is pretty expensive. So we can always add +1 configuration. We probably would not be able to like test 100 configurations.
So one configuration per platform.
Yeah, we still like we run on Trusted Firmware A in pilot, essentially still in pilot mode because development still continues. We are finding like how to do it the best ways to actually get most out of it. So we still didn't run like in full mode, and when we do, we would be able to like to say what capacity we have. For example, for page testing, we still run just a single configuration because for page testing, we would like to have like more or less real-time feedback to users. And if we run page testing for many configurations, it's just latency delay, like you need to wait a few hours. But yeah, all configurations which are required, which are needed, we can add to this test. Just like not too much, not infinite. Like we cannot run 10 more configurations than we do now, hundreds. Maybe if you want to run twice more, maybe it's possible.
Okay. Okay. And I think you said initially only mandatory rules will be scanned, and the required and advisory is would be a contribution from the community. So were you talking about the scans or were you talking about the actual fixes for the defects?
Yes, so as also both myself and Roberto mentioned, we captured as many rules as possible. It's up to filters to actually select what is interesting in the current state. And again, when given initial requirements from project maintainers. It was like we want to make sure that there are no mandatory issues. And yeah, from my understanding, please understand that I am just a CI engineer. I don't set rules and requirements. So I guess Joanna Farley would be able to answer that most. But yeah, my understanding is that project on the maintenance level, essentially on ARM level, would like to keep baseline of mandatory rules and invite the community to contribute fixes for other issues.
Right.
So just to give a bit of background, so where we've run MISRA in the past, we've aimed to clear all the mandatory issues, like as you can see this there, and then we also worked on a lot of required and advisory issues and fixed as many as we could. But it's we didn't start using MISRA when we started developing the project. It was sort of applied on a relatively mature project. And so there's a lot of sort of history and a lot of changes that would need to be made to clear everything. We made the decision not to spend a lot of resources and set a baseline. And there is a document available where we've recorded the reasons why we haven't addressed some of the issues, because some of them would require a lot of refactoring. It's not something that, it is something that could be done in the future, and willing to take contributions, as Paul has mentioned. But at the moment, we've got the baseline, and what we're trying to do is ensure that we're not introducing any new mandatory, any new advisory, any new required changes, which is why on every patch that's applied, it's set up that you can see what new MISRA issues, if any, have been shown, and we would require the submitter to address those issues. Does that help, Varun?
Yeah, thanks.
And the document, there is a spreadsheet, and I can follow up after on the mailing list where that is kept, that gives a brief description across all the different rules. We need to update it. It's a sort of living document, and it's a little bit out of date, but this is all to give potential people downstream of the project some justifications of why, for required and advisories, why they're not addressed. Because as was mentioned at the beginning, we don't go through certification for the projects. That is something very specific for people building the products based on this. But we try to give those folks a head start with the analysis that has occurred so far.
So if someone has to push a fix for one of the rules that is not currently enabled, but you take a community contribution, and they do a lot of work and fix all those issues for that specific rule, will that rule then be enabled in the scans from that point onwards, or will you still say that we won't because it's not part of the baseline?
So I think the rules are enabled, aren't they? We're just not addressing them. Is that correct, Paul?
Yeah, so currently it's more a question of what filters are set up by default. Like if we raise baseline, like address more issues, we can make the default filter report be like more flexible. But yeah, it's all possible. Like there are very flexible configurations with ECLAIR, and we would be able to do that like without much trouble, much effort. Like the biggest dependency is actually fixing the code or changing the code.
I see. So if let's say I spend spent some time and let's say there is one rule which is not part of the baseline today, and we have added some of the it is waiving of some of the issues that are seen for the rule. If let's say I spend some time and fix all those issues, and we reach a point where there are 0 defects for that rule, then from that point onwards, the system will ensure that no more defects for that rule will creep into the code. Is that the right understanding?
Yes, we can configure it to do it that way. So currently, again, it's all still like in pilot mode, and we don't, for example, fail testing builds for patch submissions, for example. It's still like up to maintainers to look at MISRA report, and contributors to make sure that, for example, that they don't introduce any issues. And for patch report specifically, all not just mandatory but required advisory issues are reported. So, for example, contributor which is interested to not introduce new required issues in the code can already act on it. And going forward, I guess we would might be make this all checks like required and not accept code, or at least like give -1 for code review if they happen, for example, for maintainers for overrides them.
Okay, thank you. No more questions for you.
So is my screen is still shared? So there is like full report which includes required and advisory. And you see there are currently 7,900 required violations and 1,000 advisory violations. As you may imagine, like addressing them all would take some effort and time. There is some kind of amplification, like some issues are reported across the code base, but there are still like enough to fix. But if some contributor party interested to fix them over time, that would be nice, and we would have less account, and yeah, we can have custom reports, which, for example, include all mandatory rules, but also a particular required. Like, and if it's 0, it's okay. If the count goes above 0, we can, for example, fail the build and not accept patch.
So one question, Paul, does this report mean that there are no mandatory reports in the tree today? Or there are no mandatory violations?
Yes, so currently there are no proven mandatory violations in the Trusted Firmware A code base.
Right, okay.
As I showed here in the first report, there are still some like cautions. It's not a violation, it's like heuristic which shows that there is something may be wrong. So ECLAIR not just proves something, but also have like some hints that something may be wrong. And there are still, so ideally, like people familiar with code base would need to review through these cautions. And if they are not real issues, like to silence them. So again, ECLAIR the tool allows it, and if there would be interested parties, we can do that. And there are still like pretty small number of these cautions, mandatory cautions, only 19. I myself looked into them so to understand how system works, but yeah, I would say they're definitely like false positives. Just need to configure ECLAIR possibly to understand these facts that they are not real issues, or just again record them as to silence them essentially.
So I've put in the chat a link to on the developer TrustedFirmware.org site a PowerPoint, not PowerPoint, sorry, a spreadsheet that shows where we've gone through the rules and which ones we have fixed and which ones are addressed and which ones and the reasons why we haven't addressed some of them due to the amount of refactoring that would be required. So that's in the chat if you want to look at that. So the analysis follows the mandatory required advisory distinctions rather than the ECLAIR violations and cautions. And this document is quite old. It actually predates ECLAIR, but it is a guide, and we will probably update it to ensure that it's compliant with the reports now being generated by ECLAIR. I don't know if you want to briefly show that, Paul, just very briefly, perhaps. It's in the chat, so you can see there's a link to a place, and there's a file that you need to download. Might be quicker. That's the link.
See? Yeah, can you see it, right?
Yeah. And there's, unfortunately, I download it, but hopefully you can display an ODS file.
Mm-hmm.
So we didn't prepare this for the presentation, but it's probably useful to show.
Yeah, just a second, let me share it. Yeah, so here it is, like for every, I assume it's every MISRA rule, it's like recorded.
Yeah, it's not showing at the moment.
Not showing, yeah, well, I'm sorry.
Yeah, no, sorry. It's, I appreciate this wasn't prepared part of the presentation.
What about now? Can you see it?
I'm not, no. It just says Paul is started to share screen. Maybe it's going to take a little while to appear. If not, people can look at it after the, oh, there we go. Yeah. So there's all the rules and which ones we've enforced and which ones we haven't. And then there's some comments on the reason why and why it's problematic. I think as we would refactor code, hopefully we could ensure that these are more enforced, but that's a bit difficult, as I said, with an existing code base without spending an awful lot of effort trying to address all the required and advisories. And if you go for certifications, you don't need the required or the advisories. You can give a justification of why you're not addressing them, which is why we've ensured that to address all the mandatory issues. Anyway, hopefully the recording will show where this is. But if you have trouble, just reach out on the mail alias, and I will point people at this. Okay.
Okay. Any other questions? Okay, then I guess thank you for listening to our presentation. Yeah, so it's enabled for Trusted Firmware A. Submitters of patches should see it, like comments from testing bot, which comments reports. So you already see it. We will improve it going forward. And yeah, we appreciate feedback. Like if there are any questions, if there are like some additional configurations, reports should be adjusted. That's all appreciated because it's done for actual developers. We need the feedback to make it useful.
Thank you, Paul. We are a bit out of time, so I think we'll stop. Thanks, Roberto and Paul, for presenting. That was very interesting. We reached a peak of 26 participants. That's a good number.
Thanks to you.
Yeah.
And to the audience, please don't hesitate to get in touch in case you have any questions. and you will find me. If you search for me, you will find me.
Thank you. I'm stopping the recording now. And thanks for the presentations.